Part 4, Introduction to Trigonometric Equations. Solving an equation requires finding a value of the variable that makes the equation true. You can have multiple answers, infinite answers, or no solution, depending on what kind of question you're being asked. If infinite answers are a possibility, they will be described as a general solution, as shown in the examples below. Knowing the unit circle will make solving trig equations much simpler, as will knowing the cast rule. So hopefully somebody talked to you in grade 11 about the cast rule. The cast rule helps you to remember which trig functions are positive in which quadrants. So in quadrant 1, the A represents all of them being positive. In quadrant 2, sine is positive. Cosine and tangent are both negatives. In quadrant 3, it's tan that's positive, sine and cosine are both negative. And in quadrant 4, it's cos that's positive, sine and tangent are negative. Okay, so if you're solving, you might have to use some factoring. You might collect like terms, use substitution, or the good old fractions. Okay, so we're going to do a few examples, and then that's it for this chapter, on the unit circle. Solve the following. 4 sine theta minus 5 equals 3. Our answer is between 0 and 360 degrees. Okay, so first thing again, we're going to get our trig function by itself. So I'm going to add 5 and then divide by 4. So that becomes 4 sine theta equals 8 and sine theta equals 2. Okay, now remember that sine theta, if you took a look at the unit circle, we started at 0, it went up to 1, back down to 0, down to negative 1, and all the values for sine theta in between there were all between negative 1 and positive 1. So is it possible for sine theta to equal 2? Well, you can try typing on your calculator sine negative 1 of 2. Make sure you're in degree mode. Okay, and you will find that that is not true. So therefore, there is no solution to this question. Okay, wow, that was pretty fun. Next one. Again, we're looking to get theta alone. So let's first of all isolate the cotangent thetas, so we'll get them both on the same side. So I'm going to subtract 6 cotangent theta from one side and add 4 onto the other side so that I can get all the cotangents on one side and everybody else on the other. Okay, so that gives me cotangent theta, because 7 cotangent theta take away 6 cotangent theta leaves us with 1. And positive 4 minus 5 gives us negative 1. Now, remember that cotangent theta can't be done on your calculator, so you're going to have to change that into tan theta. So that becomes 1 over tan theta equals negative 1. So to get tan by itself, we're going to take the reciprocal of both sides. So that becomes tan theta, but the reciprocal of negative 1 is still negative 1. Okay, note that our answers are between 0 and 4 pi. 0 can be included, but 4 pi cannot. So, in which quadrants was tan negative? Well, we go back to our cast rule. It's negative in quadrants 2 and quadrants 4. So, in quadrant 2, when does tan equal negative 1/2? Well, you might want to go back and look at your unit circle from tangent to discover that it equals negative 1 at 3 pi over 4. Okay, good. And in quadrant 4, you will find that the pi over 4 there is 7 pi over 4. Now, those answers are both between 0 and 2 pi. So we need to do another full rotation of the circle to get back to 3 pi over 4. So I'm going to actually take 3 pi over 4 and add 2 pi. Well, 2 pi does not have a denominator. Well, it does, but it's 1. So we're going to change that to 3 pi over 4 plus 8 pi over 4, so that they now have a common denominator and you can add them. 3 pi and 8 pi make 11 pi over 4. So my next answer is at 11 pi over 4. After one, so if this one's at 3 pi over 4, then I do another full rotation to get to 11 pi over 4. Okay, do the same thing with the 7 pi over 4, so 7 pi over 4 in quadrant 4. So I would take that, do a complete rotation, which means adding 2 pi. So 7 pi over 4 plus 8 pi over 4, which again is the same thing as 2 pi, would give me 15 pi's over 4. And good. If you notice again, 15 is just one short of 16, and 16 divided by 4 is 4 pi, so we know that 15 pi over 4 is still less than 4 pi, so that is fine. Okay, awesome. Now, if you get a solution that is actually right on the axes, so right on the x or y axes, whoops, okay, those are known as quadrantal. So it's a solution that's right on an axis rather than belonging to a specific quadrant. To determine what sign it's going to be, just look at whatever axis it's on, and that will help you out. Okay, so if you see this word quadrantal showing up, it's not in a quadrant, it is on an axis. Okay, let's try out the next page and finish this up. Okay, these questions are asking for a general solution. So what that means is we're going to find a solution that works not just in the first rotation, but in any rotation of the circle. Okay, so we're going to solve them the same way as we solved before. So in the first case, okay, in the first case, we're going to factor out a tan theta. So tan theta, when I divide tan squared theta by tan theta, I still have a tan theta. And when I divide the 3 tan theta by tan theta, the 3 is what remains. Okay, good. Now I have two cases. I have the case where tan theta equals 0. So theta would be, when does tan equal 0 on the unit circle? We're in degrees, so that would be at 0 degrees and also at 180 degrees. Okay. We also have the case where tan theta minus 3 equals 0. So that would be when tan theta equals 3. Okay, and 3 is not a trig thing on our unit circle. So you actually have to go tan negative 1. Negative 1 of 3. And you'll get 71, approximately 71.565. Good. Okay, so notice that 0 happens at 0 degrees, 180 degrees, again at 360. So the general solution then, we can write theta 1 equals 180 n, where n belongs to integers. Okay, so every multiple of 180, including 0 times 180, would give me a solution where tan equals 0. Okay, theta 2 is at 71.565 degrees. Now, where does tan again become negative or positive? Because if you notice, tan theta is equal to positive 3. So where else is tan positive? Well, according to cast rule, tan positive is in quadrant 4. So, or quadrant 3, sorry. So, how do I get from quadrant 1 to quadrant 3 in degrees? Well, there's a difference there of 180 degrees also. So my next one would happen at 180 degrees. And again, n representing the number of rotations. So, those would be considered our general solutions. In other words, solutions that regardless of how many rotations you made, you would get something where tan either equaled 0 or tan would equal 3. Okay, part B. Cosecant squared minus cos equals 10. And our answer is going to be in radians. First thing you want to do here is get everything on the same side. Okay, so that means cosecant squared theta minus 3 cosecant theta minus 10 equals 0. Then we're going to factor, because this is technically a trinomial. The first term is squared, followed by a non-squared, followed by a value with no term. Okay, so we're going to... Okay, so what we're going to do then is we get cosecant theta and cosecant theta, and that's going to equal 0. Okay, what multiplies to 10 and adds has a difference of 3. So we're going to use 5 and 2. Good, because it's a negative 3 and the negative 10, one guy has to be a negative, so we're going to make the bigger one negative to get a negative 3, and the other one has to be positive. All right, so we now have cosecant theta plus 2 equals 0, which gives me cosecant theta equals negative 2. Remember that cosecant is the reciprocal of sine, so we have 1 over sine theta equals negative 2. Take the reciprocal of both sides. Sine theta equals negative 1/2. Negative 1/2 is on our unit circle, and if you look at the cast rule, sine is positive in quadrants 1 and 2, which means it's going to be negative in 3 and 4. Sine equals 1/2 at pi over 6's, so we just need the pi over 6's in quadrants 3 and 4. So theta equals, and again, remember that we're told the question has to be answered in radians. So the pi over 6 in quadrant 3 is 7 pi over 6, and in quadrant 4 is 11 pi over 6. Okay, and we have cosecant theta minus 5 equals 0. So cosecant theta equals 5. 1 over sine theta equals 5. So then sine theta equals 1/5. 1/5 is not on the unit circle, so we have to go sine negative 1 of 1/5. Again, make sure you're in radian mode. Theta will equal 0.201. Now, that's a positive 1/5, which means we have another answer. So this guy's in quadrant 1. We have another answer in quadrant 2. So if we add a page here, okay, then we look at our circle, 0.201, okay, is here in quadrant 1, and that's our reference angle. So in quadrant 2, where y is also positive, this is going to be 0.201, okay? So how do I figure out from the initial arm to the second terminal arm? Well, remember that a full rotation to the negative x-axis is pi radians. So to figure out the difference, I'm going to take pi and I'm going to subtract 0.21, and I will get 2.940. Okay, so that would be our other angle in terms of sine. So it also equals 2.940. Okay, now I still haven't written these in general form, so I'm just going to do that on the next page where I have a little bit more room. Okay, so theta 1 was 7 pi over 6. Now, to get for a full rotation, because 7 pi over 6 is right here, okay, so there's 7 pi over 6. Okay, I need another full rotation. In terms of radians, that's the same as 2 pi. So I'm going to add 2 pi n, and again, n belongs to integers, where n represents the number of rotations around from the terminal arm to the terminal arm again. Okay? All right. Theta 2 was 11 pi over 6, and again, to make a full rotation from 11 pi over 6, I have to add another 2 pi n. Okay. My third angle was at 0.201, and to get a full rotation of the circle, I'm going to add another 2 pi n, and belongs to integers, and theta 4, okay, was 2.940 plus 2 pi n for a full rotation of the circle to get coterminal angles that are of the same value. Okay, so that is the final answer for number 2b. Okay, last example. If cotangent theta is equal to negative 9/5, determine the value of cos theta, where our angle is between pi over 2 and pi. So remember that cotangent theta is equal to x over y, so that's going to be 5 over 9. Now, which one does the negative go with? Well, if we're in between pi over 2 and pi, that is quadrant 2. So who is negative in quadrant 2? That would be our x value. So we'll make the negative with the 5. Okay, so cos theta is equal to x over r. So I have x is equal to negative 5. and I have y, which is equal to 9. So in order to find r, I'm going to use the Pythagorean theorem. So that's negative 5 squared plus 9 squared. So that gives me square root of 25 plus 81, which is the square root of 106. Okay, so I'm going to substitute that in. X was negative 5, r was square root 106, and I should probably rationalize that because I have a radical in the denominator. So that's negative 5 root 106 all over 106. Okay, that does it for the unit on the unit circle. And again, make sure you're practicing page 211, and feel free to watch the video again if you need to be refreshed. All right, good luck.